morning to panels and judges. We are from Team Mitochondria. So we would like to present our idea, which is a co-op food powerhouse. So this is a collaboration between Temasek Polytechnic Singapore and also University Technology Malaysia. So our collaborations are being departed by engineering and also architecture. TP side will more on research, simulation, and documentations, where UTM side come up with concept, design, and graphic boards. So this is the organization chart and how we actually manage our team. So first, we realized that the agriculture in Singapore is a very small industry, composing just about 0.5% of the total GDP. So Singapore produces about 22,458 tons of vegetable, while populations consume 524,462 tons of them. This is from the source of Singapore agriculture. So Singapore realized this issue and they came up with this policy, which is called Singapore 30 by 30. So what it's all about? So the aim of Singapore 30 by 30 is to produce 30% of Singapore nutrition needs locally by 2030. With just 1% of Singapore land set aside for farming, so they know that it is significant to uplift the productivity in the coming years. So there are actually few ways and innovative ways they have done to increase the productions. So this is the current actions where they have converted the HDB parking lots on top to become the urban farming area, and even have food bank and even the farm market in Singapore. But what is the implication is that it actually costs higher compared to a very conventional distribution due to a small scale. So what do we propose from all these issues? We would like to propose a co-op food powerhouse. It's a combination of DFMA, which is a modular construction, productions, which is urban farming, distributions through market, and also logistics. So we have come to a conceptual prototype in a bigger scale where we wanted to introduce a co-op food powerhouse chain link. The food powerhouse will be designed and being placed in a certain radius within the community. So we realized that the existing park actually creates a very good opportunity where it being set by a certain radius to serve certain community. So what if we are able to take advantage of the existing park and place our co-op food powerhouse with the integration of marketplace, which relates to their everyday life. So this enables to create compulsory activity, further result on the resultant activity, which is our education. So we would like to choose a site which is at Bishan, near the Bishan Park. So our site is 3 acres and is located within the Ang Mo Kio residential and also the industrial park. This is a good opportunity to bridge the both district by using the Bishan Park resources. From these combinations of 4 different typology, it enables to create a sustainable mixed development by itself. So each of the program able to complement each other by creating a sustainable development. The bird-eye perspective showing the food powerhouse, how it able to connect Xinmin Avenue and also the Bishan Park, which directly linked by this marketplace. So on the sustainable feature, we first designed by using the form. So we studied the sun path. We realized that we are facing east and also the west. So we place the farming tower on the west side where it enables to filter most of the sunlight to provide better shading for the HDB housing. So these are some of the daylight analysis. So it showed that it received maximum sunlight, which enables to filter so many of this natural daylight for the farming to have photosynthesis to produce food. And the next sustainable feature will be the passive design. We have adapt solar panel and also the photovoltaic glass panel. Solar panel are being placed on every rooftop, and the photovoltaic glass panel are being placed on the facade facing west. In this case, able to benefit two different things. First, able to generate the electricity, at the same time, able to provide photosynthesis for food productions. So on the right side, you can see is how a photovoltaic cell works. And the next one is the modular design. The modular design we have separate into 5 levels as one module. So you can see from module 1 to module are the same, just that it's repetitive in every 5 level. So this is a single module. When we explode, we can see that on the very bottom will be this hydroponic farming, and on top will be a traditional farming. So what's the reason to actually place different type of farming in one module itself? Is we realize that one of the biggest issue in hydroponic farming is that it creates high humidity within the spaces. So with traditional farming, where it's open spaces, it's able to balance the level of humidity throughout this entire module. So this is the modular design. As you can see on the left side, we have HDB, and it's being separated by module 1, 2, and 3. And on the podium level will be a distribution port and also the market space. So another sustainable feature is that we are using the logistic, how we're going to transport our food productions from the higher level towards the podium level. So we are introducing this aero lift. So it has a 270-degree surround vertical transportation. The photovoltaic glass panel can be opened up and able to transport the farming rack out from this area when it's ripe, and also transport to our packaging and logistic level. So as you can see from here, it's being transported all the way down core towards our packaging level or towards our distribution level. So when it's done packaged, it can be distributed through land transport, where we have a port here, or through our drone transportations. We believe that easing transportation is the way towards a much more sustainable development. So these are some of the perspectives from the market. So this is the market perspective from the Bishan Park itself. So what we're trying to create that is that using marketplace as a great alternative for compulsory activity, where it has market for retail and supermarket, and what it results is that it able to educate people how their food is being produced, and exposure towards the process of food packaging until distributions.
Autodesk Construction Cloud has been a cornerstone of our project as it enhances team collaboration. We've used the platform to store design documents, drawings, specification, and other critical project information. This centralized approach ensures that everyone involved is working from the most up-to-date and accurate information, minimizing confusion and errors. There's also software such as Fix, which helps to track assets and optimize facility operations. With Fix, maintenance is done by scheduling routine inspections, servicing, and repairs based on asset usage and manufacturer recommendations. We simulate airflow patterns, thermal comfort zones, and contaminant dispersion. This enables us to identify potential hotspots, optimize ventilation strategies, and create environments that prioritize occupants' well-being. So synchronizing the 5S of the Lean, our billing programs generates the billing form as it is. Each program is segmented in group orders to ensure a clean and efficient flow. Our timeline defines when construction activities commences, ensuring the resources are mobilized, contractors are engaged, and work progresses smoothly. This phase accounts for project management, quality control, and site safety. After some rough calculation and not considering any flaws, our billing will take about 752 days until completion.
So opting with the DFMA for construction brings about several crucial benefits, such as a reduced timeline, improved surrounding conditions, and the reduced reliance on manpower. PPVC also allows for a constant floor plan for every level, where affected the cuboid form of the building accentuates the reduction of cranes and its movements within the site. As the units come pre-made, the hoisting workload would be highly reduced as time waiting constraints are eliminated, allowing the hoisting to begin as soon as the units are available. As you can see for a residential segment, the DFMA is as per follows. 2 of unit type A1, the 3-room with balcony, 4 units of type A2, 3-room unit without a balcony, and 1 unit type B, which consists of a 2-room unit for each story. The process of actually generating these prefab units highly reduces manpower and materials, as the generating has accommodated for all the further installations per unit or per floor. So here are some of the softwares used and collaborated on throughout this entire project. Key apps such as Microsoft Teams, BIM 360, ACC, and PowerPoint furthered the collaboration between UTM and Temasek Poly, especially when facing clashing schedules from each institution. So in summary, our proposal was generated from the realization of the necessity and concern for locally sourced foods, which highlights key contributing stakeholders and their part in the agriculture sector. As for collaborating as Team Mitochondria, we blended our diverse nationalities and backgrounds to empower us and gain valuable insights from one another. So food security is not just about having enough to eat, it's about empowering communities to grow, share, and thrive together. Thank you.